Today's lesson will be on angles and their measure. A ray, which you studied in geometry, which is sometimes called a half line, is a portion of a line that starts at a point V on the line and extends indefinitely at one direction. The first thing I want you to realize here is that a ray has a starting point. The starting point V of a ray is called its vertex. If two lines are drawn with a common vertex, they form an angle. This is another definition you should remember from geometry. One of the rays of an angle is called the initial side, and the other is the terminal side. Notice in the pictures on the PowerPoint that these sides are labeled. So we're going to call one of these the initial side and one the terminal side. It depends on which way things are rotated. We can have three different types of rotation. This first one is a counterclockwise rotation. This results in a positive angle. The second one, I'm just going to be labeling I for initial and T for terminal. If I rotate this around the other way, then I have, let's go this way, then I have a clockwise rotation, and this ends up being a negative angle. We'll call this one beta. Okay, a counterclockwise rotation, remember, is a positive angle, and a clockwise rotation is a negative angle. You can actually rotate these angles more than once. So if I start here and I rotate, this one is the third example here. If I rotate all the way around and then keep going, the initial side being here and the terminal side being here, this is still a positive angle, and we'll call this one gamma. This is still a positive angle. However, it is an angle that is more than 360 degrees. An angle theta is said to be in standard position if its vertex is at the origin, and we're talking just about the regular coordinate plane here, the rectangular coordinate system, and its initial side coincides with the positive x-axis. So if I'm going to draw an angle in standard position, I'm always going to draw my angle on the standard coordinate plane, put its vertex at the origin, the initial side is always on the positive x-axis, and then I'm going to rotate and draw my terminal side. This is a positive angle in standard position. The second picture on the slide here is a negative angle in standard position. When angle theta is in standard position, the terminal side will either lie in a quadrant, in which case we say that theta lies in that quadrant. So in this picture that I've drawn here, we say theta lies in quadrant 2. See if I can spell today. Okay, theta lies in quadrant 2. And as a quick review, hopefully you remember this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Or it will lie on the x-axis or the y-axis, in which case we say theta is a quadrantal angle. So if we have, let me scoot over just a bit, if we have an angle in standard position that looks like this, we say theta is quadrantal. This is a quadrantal angle, because it does not lie in a quadrant, but it lies on the x or y axis. Okay, so again, just some examples of what I've drawn over here already. Letter A is where theta lies in quadrant 2, just like the one I drew. Letter B, theta lies in quadrant 4, and in letter A, theta is a positive angle. In letter B, theta is a negative angle. And letter C, theta is a quadrantal angle. It's also positive. We measure angles by determining the amount of rotation needed for the initial side to become coincident with the terminal side. Angles are commonly measured in either degrees or radians. Now, hopefully you remember degrees from geometry and from what we've already done in this class. We will be working with radians shortly. So these are the two ways that angles are commonly measured. You can also measure angles in rotations or revolutions. The angle formed by rotating the initial side exactly once in a counterclockwise direction until it coincides with itself, which is one revolution, is said to measure 360 degrees. So hopefully you remember this from geometry as well, because you remember a circle has 360 degrees. So if I start at the initial side, rotate the initial side all the way around until it coincides with itself, then you have one revolution. That's, if it's counterclockwise, that's positive 360 degrees. 1 degree is 1/360th of a revolution. A right angle is an angle of 90 degrees or a quarter of a revolution. A straight angle is an angle of 180 degrees or half of a revolution. Now, if we were going to draw an angle that was negative 130 degrees. Actually, let's just change paper here so that we don't get confused. Okay, if we were going to draw an angle that was negative 135 degrees, I know you already have a picture here, but I want you to kind of follow along as we draw this together. Okay, I'm going to put my initial side on the positive x-axis, and then I'm going to rotate not counterclockwise, okay, but I am going to go clockwise because clockwise makes the angle negative. So if I rotate from here to here, that's 90 degrees. So I know that if I want to go 135 degrees, I've got to go 45 more. So we're going to be halfway in between into the third quadrant. This is negative because I went clockwise, okay, and I went 135 degrees clockwise, so it is negative. Initial side here, vertex at the origin, and terminal side here. Okay, this slide's a little bit harder to follow because it's animated for class, but we'll draw each of these so that we can see them. Let's move this way. Okay, the first one asks us to draw a 45-degree angle. Well, vertex, initial side, 45 degrees is halfway between 0 degrees and 90, and since it's positive 45, we're going to go in the counterclockwise direction. So this is a 45-degree angle. Okay, a negative 90-degree angle. Okay, vertex at the origin, initial side on the positive x-axis. This time, because it's negative, we're going to go in the clockwise direction, and we're going to go in the clockwise direction 90 degrees. So this is a negative 90-degree angle. Okay, the next one that they want us to draw is a 225-degree angle. Vertex at the origin, initial side on the positive x-axis, and we're going to go 225 degrees, and it's positive. So we're going to go counterclockwise. This is 90. This is 180. This would make 225. 225 is 45 more than 180. So this would be a positive 225-degree angle. Now what I want you to do is pause this video, and I want you to try to draw a 405-degree angle. See what you can do with that. I'm going to go ahead and draw my axis here, and at this point I'd like for you to pause the video, and then after you've drawn your angle of 405 degrees, I'd like for you to come back and check to see if you did it correctly. Okay, Now, let's go ahead and draw our 405 degree angle. It's positive, so we are going to go in the counterclockwise direction. So I'm going to start here and I'm going to go around 360 degrees. 360 degrees. Now I've got to get to 405. So 40 more would put me at 400 and 45 more would put me at 405. So I'm going to move halfway into this first quadrant, draw my terminal angle, or I'm sorry, terminal side, and this would be a 405, and I wrote 450. Let me fix that. A 405 degree angle. Please notice that the only way I'm going to be able to tell the difference in these angles is by drawing this arrow showing which way I have rotated. And in some cases, like the 405 degree angle, how many times around I have rotated. So that is an absolute must when you're drawing these angles. You have to put that in there. 1 minute is denoted as 1 with a little hash mark up at the top, and it's defined as 1/60th of a degree. 1 second is 1 with 2 little marks. It's defined as 1/60th of a minute, or 1/3600th of a degree. 1 counterclockwise rotation is a positive 360 degrees. 60 minutes is equal to 1 degree, and 60 seconds is equal to 1 minute. What we're going to do next is convert 30 degrees, 12 minutes, and 55 seconds to a decimal in degrees. So 30 degrees, let me move my paper down, 30 degrees, 12 minutes, and 55 seconds. Well, we're going to change this to degrees, so this first part is already in degrees, so that's 30 degrees, plus 12 minutes. I want to change to degrees, so I'm going to use my conversion factor of 1 degree is 60 minutes, and I'm putting the minutes in the denominator because I want these minutes to cancel out. Plus 55 seconds. I want to change this to degrees, so I'm going to put my seconds in the denominator. So 1 degree is 3,600 seconds. Now I can just, these will cancel, and so now I have all degrees. So now I can just go to my calculator and I can say 12 divided by 60 is 0.2, and 55 divided by 3,600 is 0.01528. I take 2/10 there. And then I'm just going to add all these together. So this is 30.21528 degrees. And this is how we change from degree, minute, second form to degrees. And now we can go in the other direction and convert from degrees to degree, minute, second form. And to do this, we're just going to put this in expanded form. So this is 45 degrees plus 0.413 degrees. And if we want these degrees to cancel right here, we're going to multiply by 60 minutes over 1 degree, because that's my conversion factor, and I want my degrees to cancel. And when I do that with my calculator, I'm going to get 45 plus 0.413 times 60 is 24.78, and now I've changed that to minutes. So now I have, whoops, I left off my degree sign. Now I have 45 degrees plus 24 minutes plus 0.78 minutes, and I want to change these minutes to seconds. So I'm going to multiply this by 60 seconds in 1 minute. I put the 1 on the bottom again because it's the minutes and I want that to cancel. So 45 degrees plus 24 minutes. Now when I multiply these two together, I'm going to get plus 46.8 seconds. Now, when I write this in degree minutes seconds, I do not need the plus signs in between. So to write this in degree minutes second, that's 45 degrees, 24 minutes, and I'm going to go ahead and round this to the whole second. So that's 47 seconds. I think we'll stop here because we've already used up about 15 minutes, and we'll get another video later.